I have one default route here. Next of IP address, through this default route, internet is reachable. And which routing protocol I am running between P and C? OSPF. So IP protocol summary, we are running OSPF process ID 1, and so run section router OSPF. If you will see, we are redistributing default route, default information originate command is running, right? So R4, this customer edge router will advertise this default route to provider. Let me access R1, and on R1, so IP route VRF IBM. In IBM VRF routing table, you can see we have one default route coming through OSPF routing protocol. You can see prefixed IP is external, OSPF external prefix. And if I will show you the configuration, so run BGP section router, so run section router BGP. Then here is my BGP configuration. You can see address family VPN v4 neighbor 3.3.3 activate, send community extended great. Then address family IPv4 VRF Dell. For Dell VRF, we are just redistributing OSPF, but for IBM VRF, you can see we are redistributing OSPF process ID 3 as well as default information originate. But the default information originate command is not working. If you will check MP BGP, so BGP VPN v4 and VRF IBM. If I will show you the MP BGP table of IBM VRF, then you can see default route is not showing, right? Default route is not present in BGP table. We had discussed this in last class, correct? So there is no any meaning of this default information originate command. What you can do, instead of default information originate command in BGP, you can run network 0.0.0 command. It will start advertising default route in MP BGP. Let me show you. A router BGP is number 500, address family IPv4 unicast VRF IBM and network 0.0.0. So after a network 0.0.0 command, so IP BGP VPN v4 and VRF IBM. Here you can see router 1 has imported the default route 0.0.0 in MP BGP. Now this P router will advertise this to remote P router, means to R3 also, because it has installed it in their BGP table. Now let me check R3 here, and on R3, so IP BGP VPN v4 VRF IBM. Here you can see the default route is coming from 1.1.1, and MPLS, OSPF, MP BGP, those all are already running, working fine, no issue. So default route is coming on remote P router. It will also install it in their VRF routing table. So IP route VRF IBM, default route is imported, and we are already redistributing BGP into OSPF. So run section router OSPF. Here you can see we are redistributing BGP into OSPF. Redistribute BGP, like in IBM VRF, redistribute BGP 500 matrix 100 subnet. This one, will this command redistribute default information originate like default route? Will I have default route on router number 5 on remote customer edge router? So IP route, see default route is not there. So you can try to run default information originate on remote P router on R3 router OSPF 1 VRF IBM. For IBM VRF, sorry, what is the process ID for IBM? OSPF process ID, it's 3, and then default information originate. You can also use albase keyword. If default route is not present in the local routing table, then also it will advertise one default route. Now go to R5, and check routing table. Here you can see default route is now coming. Okay, now if I will ping 8.8.8 from here, ping 8.8.8.8, then ping should work. But is ping working? Is ping working? Ping is not working. Let me do one thing on internet router. I am going to enable debugging, debug IP ICMP, and now ping, check if reply is reaching to internet router. Yes, request is reaching to internet router, but internet router is not able to send reply. Reason, destination IP address. It mean what? It mean NAT is not happening, correct? For side 1 NAT is happening, for side 2 NAT is not happening. Question is why NAT is not happening, Praful? We have already configured NAT on router number 4. So run section NAT. Here is my NAT configuration, IP NAT source inside list, right? List number 10, access is number 10. We are matching source from list number 10. So whatever source will match in list number 10, it should perform translation. So access list, you can see an access is number 10. We are not matching any submit, means match all. Why it is not performing translation? Because this interface is not configured as inside. The interface which is connected with P router must be configured as inside. Let me try to configure this interface as inside. Interface G0/1 IP NAT inside. And now from router number 5 you can try to access internet, and now you can see internet is accessible. Even from the source interface you can try to access, like from the LAN interface G0/1, right? So both side users are able to access internet now in IBM. But see, there is no any direct internet in side 2. We have centralized internet access. Internet service is in side 1 only. So side 2 user, side 3 user, any other side user will access internet through side 1 in IBM. In Dell we don't have internet. Service provider can also advertise one default route. You can ask to service provider, hey, I need internet access as well, and will start advertising on default route. Then configure internet like NAT on your router and access internet. You can access internet after that. So there are two ways for internet access we had discussed in last class. Now in last class, site 2 user was not able to access internet. Now site 2 user are also able to access internet. Done. This one is done, guys. Any question here? One thing is pending. One more thing is still pending here, that is backdoor link. I will show you the configuration of backdoor link as well for Dell. Right, like if service provider will goes down, then connectivity will goes down. So that's why here we have one backdoor link. Like it can be your lease line link, it can be your MPLS L2VPN, right? It can be any other transport. And here which protocol we are running? We are running OSPF routing protocol. So what was the issue after configuring this backup link? What was the issue? Backup link was becoming best path, right?
Primary path.
Primary path. But we don't want that. We want primary path should be the MPLS, right? This should be backup path. Why this path was becoming primary path?
Metric. AD
So
value.
if I will configure lower metric here, let's say metric 10 and OSPF cost over here is 20, then sorry, here 20 and here 10, will it work?
No.
It will not work. Why? Why it
That
will not
backup
work?
path is advertise LSA1.
Direct
No.
neighbor. It is forming direct neighborship, no?
LSA1 is
Here
advertised over
prefix is
that
C, OSPF check metric after route type.
after
First
routing.
OSPF check route type, and here prefixes are coming in form of LSA1, and here prefixes are coming in form of which LSA?
Let's
LSA7.
say 7 or 5.
5. Redistributed external prefixes,
Yes.
right? if you have different area here, let's say this is area 0, this is area 1, then in which form of LSA side 1 prefix will come inside 2?
Let's say 3.
5.
LSA 3 or 5? It means you guys have not tested. Try this lab. Yes or no? Anyone have
Yes.
checked or not? Hmm?
No, this lab where I haven't checked.
Haven't checked this lab. Okay. So what is the issue here? Issue is
Can you
LSA.
tell which
Here
LSA
prefixes
will
are
plus?
coming in form of LSA 1, and here prefixes will come in form of LSA 5. That is the issue. So what we want to receive remote side prefixes through OSPF in form of LSA 1 here. You can do that. You can achieve it with the help of one virtual link over service provider, like between P1 and P2. What you can create? You can create one SAM link, OSPF SAM link. It is similar like OSPF
Virtual link.
virtual link, yes. And you can advertise this SAM link in OSPF area 0 or area 1, right? Again, if you will advertise it in area 1, then prefixes will come in form of LSA 3. Again there is issue, so make sure area is also same. And after that, when from both side prefixes are coming in form of LSA 1, then with the help of cost you can manipulate the path. Then you can configure lower
So
cost here and higher cost value here.
okay, one more
So,
thing. One
sir,
more
sham
thing.
link and virtual link, they're not the same thing?
Go one by one. Yes, not same thing.
Virtual link and sham link, they're not the same thing?
No.
Okay. Can you tell me
So
the difference one more time, please?
Virtual link is created between normal router, not over MPLS. If you
Okay.
remember, virtual link is used to connect two regular area to backbone area. That is the use of virtual link in OSPF. Area 1, area 2 and area 0. Right? So here we create virtual link to connect area 1 to area 0 over area 2. That is virtual link. And over MPLS we are creating virtual link that is called SAM link. Yes, someone else
Thank you,
was
sir.
asking question.
no, so this will, this service provider network we are not able to see, right? So what the configuration service provider has done at their end. So how to create this SAM link or whatever,
Service
or we
provider will
have to,
create.
okay,
Have
we
you
have to
configured
give our
MPBGP?
requirement, right?
Have you configured MPBGP?
No, no, service provider has configured this.
Have you configured MPLS?
No, no. So anyway, just my question is that, so we have to request this requirement, right?
Correct.
Okay, great.
We have to request for OSPF SAM link to service provider. Service provider will create one SAM link between provider to provider, P to P. How? They will create one loopback. First, they will make reachability between those loopback through any routing protocol, through OSPF routing protocol. And after that, they will create SAM link like we create virtual link in OSPF. Similarly, there are some command. Let me show you. Go to R1.
And show some show the path manipulation also, how this LSA is advertising in this
You have
in
to
Labsen.
you have to learn OSPF again, brother. In OSPF we had seen this. Definitely here I will manipulate the
This
path.
here I want. Actually, I'm learning OSPF, but here I want to see this.
See, on the customer router, Path manipulation will be same. On customer router only I will change the cost value. So it is similar like this. Customer on the customer router we are not running MP BGP, we are not running MPLS. Normally this router is receiving OSPF route from two neighbor. So from one neighbor I want to receive better path, so I will change the cost value. There's nothing. That's very easy. And if you have not understood
No,
that thing,
that understood how
then
to change the
I
cost
think it
value.
will be difficult to understand MPLS. Right? These are very advanced concept. Okay. R1 and R3 both P router. Let's do one thing here on R1. First of all, let me check the configuration. Interface loopback 10, and I'm going to put this interface in VRF IBM IP VRF forwarding IBM IP address, let's say 100.1.1.255.255.255.0 or 200. I think 100 is already running in somewhere. 200.1.1.1 255.255.255.255. Then router BGP 500 address family IPv4 unicast VRF IBM and network 200.1.1.0.1 mask 255.255.255.255. Do so IP BGP VPN v4 VRF Dell. In Dell VRF prefix is not installed, so IP route VRF do so IP interface brief loopback 10 and do so run interface loopback 10 IP VRF. Oh, I have added it in IBM VRF interface loopback 10. No IP VRF forwarding IBM. Remove it from IBM. Okay, and IP VRF Dell. Then IP address 200.1.1 255.255.255.255 exit do so IP BGP VPN v4 VRF Dell. Do so run or do so IP route VRF Dell. Check 200 is installed or not. Yes, it is installed. Then router should install it in BGP as well. Do so run section router BGP. Router BGP 500 address family IPv4 unicast VRF Dell and network 200.1.0 or 1 mask 255.255.255.255. Do so IP BGP VPN v4 VRF Dell. Now this prefix is installed and we are redistributing BGP into OSPF, so service provider will also advertise these 200 prefixes to customer, right? First of all, I don't want that. I don't want to advertise this to customer edge. Tell me how to control it. how to control it, like on customer edge router on R6. So IP route, you can see this submit is coming, right? But this is not customer prefixes. How to control it, how to stop it from being advertised from P to C?
Route map.
I only want to advertise this to remote PE router, not to customer edge router. R1 should advertise it to R3, not to R6. On R3 also you will find this. Do
through
so
VRF.
so IP BGP VPN V4 VRF Dell. Here you can see 200 is coming. That is great, good. But I don't want to advertise it to customers. Tell me how to stop it. Huh?
With the help of route map, where we can create
If the
prefixes.
VRF is same on both ends, it won't leak. Unless your route leaking, it will
Huh?
leak to other people.
What you are saying here? With the help of route map on R1, first of all I have to get one access list, right?
Correct.
To deny this
Hmm.
200 subnet and permit rest everything else.
Hmm. Correct. Then
So
apply filter to
let me,
OSPF.
yes, access list, let's say number 10, deny 200.1.1.1 wildcard mask 0.0.0 and access list number 10 permit any. Then use this ACL in route map, let's say CCI permit sequence number 10, and here I am saying match IP address from list number 10. Match IP address from access list number 10. In list number 10 we are denying one, the loopback IP address where service provider is created, right? Rest everything is allowed. Then exit and do so run section router OSPF. So see which OSPF process ID is running here. I think 2 router OSPF, 2 VRF Dell, and here I am saying redistribute BGP 500 matrix, this one. So I will remove it and here I will use route map. So router OSPF 2 VRF Dell, and say no to this redistribution command, and then again same command redistribute BGP 500 matrix 10 and subnet, then route map CCI. Correct? This is how you will control it. Now on the customer router, if you will check routing table, you will not have this 200 subnet. Soon it will flush it. Clear IP route and so IP route OSPF. Now you can see 200 is still coming. It means I have not created the route map properly. Let me see here on R1 redistribute BGP 500 matrix 100 subnet route map CCI do so route map CCI match IP address from access list number
So do we have to give the direction in or out
No, no,
in OSPF?
no.
Okay.
You guys forget OSPF. Access list number 10. Deny 200.100. This is also correct. I'm missing anything. 1 minute. Okay, from where it is coming? So sorry, it is coming from backdoor link, from the backup link, guys. Extremely sorry. Earlier 200 was coming from R1, now it is coming from this side. How it is coming? Like R1 is advertising to R3, R3 is advertising to R7, R7 is advertising to R6. You can see next hop IP address 172.16.1.2. This submit is running over here on this link, on this backup link. Right? Here you have block it, stop it. On R6, this prefix is coming from backdoor link. Okay, no problem, just wait. Go to R3 and do same thing on R3 as well. On R3 also create one loopback number 10, IP VRF forwarding IBM, sorry, Dell, and then IP address. Let's say 201.101.1, 255.255.255. Exit router BGPS number 500. Address family IPv4 unicast VRF Dell, and network 201.101 mask 255.255.255.255. Now again on R7 you will learn it. So IP route OSPF, you can see 201.1.1.0 is coming from 37.3. Which router? From R3. Now here also I will control. From R3 I will not advertise this to R7, and I will advertise everything else. So like here you have only deny 200.1.1.1. You can also deny 201.1.1.1, both the IP address. The loopback on P1 and P2. In my access list on router number 1, I can do one thing here. In my access list I can modify it, right? But see 201 is coming from the provider edge router here. So first go to R3 and let me repeat this step. Access list again number 10 here, deny 201.1.1.1 wildcard mask 0.0.0, and access list number 10 permit any route map CCIE and match, sorry, action route map CCIE permit match IP address from list number 10, exit router BGPS number 500, address, sorry, not BGP, router OSPF to VRF Dell, and do so run section router OSPF. Here is your redistribution. Say no to this and use route map with this redistribution route map CCIE. Now go to R7 and check routing table. Clear IP route star and show IP route. Hmm. Do so route map, do so access list, deny 201, do so run section router OSPF, redistribute BGP for SQ. One access and 1 minute. Router OSPF. Keep yourself on mute, guys. Okay, when I'm not redistributing, then also these PPs are coming. Let me check the configuration properly. So IP route OSPF R7 good R3 do so run section router OSPF to VRF del redistribute okay. Now go to R7 and check. .3 200 on coming in form of reason. Here is the reason. So no network 0.0.0, it is redistributing loopback 10 also in OSPF network 37.1.1.0 0.0.255 area 0 and now redistribute this, because now if you will not redistribute, here you can see prefix will not come, so IP route OSPF, clear IP route still network 0.0.0 command is running. Router OSPF to VRF Dell, and do so run section router OSPF to VRF network 37.1.0 area 0. Mm, 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 mm. So IP OSPF
That route's coming from backdoor, I think.
redistribute BGP 500 metric 100 subnet and route map CCI. Okay, 192.1.1.0 reachable through backdoor. Ping 201.1.1 source 200.1.1. VRF Dell. Okay, these two loopbacks are reachable in Dell VRF. Now let me try to configure SAM link here. Config T a router OSPF process ID 1 VRF A, sorry, VRF Dell.
So route map work here?
Yes, working now.
Okay.
Process ID is 2 and area area 1 SAM link. Okay, SAM link. Source IP address is 200.101. peer IP address is 201.101. Cost not configured now. Router OSPF to VRF Dell and area 1 SAM link, local IP and a remote IP. OSP अपनी वर्षिप is a power SAM link. So IP OSPF neighbor router ID. So now go to customer edge router and check routing table. So IP route OSPF. Now here on the what is the cost? Cost over is 2. Let me configure G0/2 IP OSPF cost 5000 and clear IP route star. So IP route OSPF. For a moment, I'm going to down backdoor link shutdown. So IP route OSPF. Okay, here now you can see these prefixes are coming. Side 1 prefix is coming in form of LSA3 now. In form of LSA3. Here cost value is 101. Our backdoor link cost value is 5000. Still it is preferring. Still it is preferring backdoor link. Now what I will do, I will up this link first, backup link 0/2, say no shutdown, and on provider edge router, instead of running this command, yes, say no, and then I'm going to set area 0 R3 config T router OSPF2 no. OSPF is up. Go to R7 and check routing table. So IP route OSPF 192.168.1.0. 192.168.1.0 is reachable through R3, means through MPLS link, and if MPLS link goes down, interface G0/0. Here you are learning this 201 submit also, so you can check the route map and you can block it, like through route map access list we can block it. So if I will down MPLS shutdown and then do so IP route OSPF, then 192.168.1.0 is reachable through backdoor link, right? Again, when my MPLS will come up, again your when MPLS will come up, it will install the primary link, MPLS link 37.3. So or from R6 you can trace or just check routing table, trace 192.168.2.1, source 192.168.1.1. Even if you want load balancing here, now you can configure same cost. Now our both the link OSPF prefixes are coming in form of same LSA 1. So we can control the path through, cost. So IP route OSPF 192.168.2.0. Here still you can see best path is through backdoor link. Configure higher cost value, interface G0/2, IP OSPF cost 65535, and then check routing tables. So IP route OSPF now 192.168.2.0. soon it will update routing table. Now you can see 192.168.2.0 is best from 16.1 R1. Right, you will have these kinds of scenario in CCI lab exam. This way you have to set up two site. SHAM link is part of CCI lab. Clear, guys?
Yes, yes.
Right, so our service provider network, our MPLS, also we can create virtual link, OSPF virtual link, which is called as SHAM link. The concept is same. Like this only we had created virtual link also, if you remember, right? The purpose was different. Here we have created SHAM link for customer so that service provider can advertise OSPF route. Right? Earlier service provider was advertising only redistributed route because MPBGP is the only protocol which we can run between two PE. MPBGP is the only protocol which we can run between two PE for VPN v4 route exchange. And here it is like how it's feel, how customer will feel. Customer for customer you can see both the sites are connected through OSPF. Like OSPF is running over here. OSPF. Now OSPF is running on both link with the help of cost or whatever manipulation you have learned in OSPF, you can use that for path control. So simple. There is one more thing in MPLS, that is MPLS L2 VPN. After that we will move to a VPN over internet transport. Okay, so can I start L2 VPN configuration? We have discussed the theory part, but we didn't configure L2 VPN. Can we see MPLS L2 VPN? Like how provider can provide L2 link. Now what you know, service provider can also give the OSPF route between two sites, P1, P2 and some provider router, provider 1, provider 2. Now how service provider can provide L2 link to customer? When service provider will provide L2 link to customer, it means what? Two sides of customer will be in same subnet, right? We have discussed two VPN. Can anyone remind me the name of both L2 VPN? Again in the service provider, you will have one loopback here on the P, on both P. Loopbacks will be reachable through OSPF routing protocol. You will have MPBGP and MPLS. MPLS must be enabled here. This is MPLS routers. And here are customer. For customer, this entire transport is going to act as a link, like a fiber cable. C1, customer is 1 and customer is 2, right? So if this is acting as a L2 link, it means you can imagine like these two cables are connected like this. Like this or like this. Service provider will make you feel like both the C routers are connected through single fiber. So you can configure one subnet here, 10.1.1.1 and 10.1.2. And when 10.1 and 2 are reachable, you can configure any routing protocol here, correct? This particular thing is called MPLS L2 VPN. We had discussed two VPN here. Can anyone remind me the name? I had told you we'll discuss EVPN, like the theory of EVPN later.
VPLS,
Yes, VPLS and
EVPN,
no.
it's under VXLAN.
L3 VPN.
I had told you L2 VPN and L3 VPN. In L2 we had discussed 2 VPN. I told you one VPN was point to point, VPWS, virtual private wire service, point to point connection like
Just
lease line
pseudo
connection.
wire.
Yes, and VPLS. Okay, we can test both the protocol here in EVNG. On this router, I think commands are not available. I can use GNS3 or I can use another topology here, the simple topology. Even this topology is complicated. Let me do one thing. Let me use this topology. So simple. Let me see if I have any another topology here. Here. Okay, this one is good. MPLS L2. Put yourself on mute, guys, getting noise. Yes. And here you can see in my all lab between 2P I have one path, right? You can create multiple lab, you can have multiple paths like lots of provider router, but there is nothing to discuss because we have already discussed the OSPF routing protocol. How two provider will be reachable with each other, right? In real service provider network, every time you will have lots of path between two provider. Just give me 1 minute. Here I am going to change few things. This is not BGP. Now this is not IPv4 BGP. This is service provider and OSPF BGP 500 and MPLS. MPLS between P to C you can configure any routing protocol, right? But in MPLS L2VPN we are not going to configure any routing protocol between P to C. Provider, there will be no any involvement of provider in customer routing. Provider will give you the link, that's it. Like this. Let me access the router. First R1. R2. R3. No, no, no. Let me use Notepad for the configuration. Basic configuration. First of all, my loopback, both the loopbacks should be reachable. 1 minute, guys. See, enable config T interface G0/1 no set IP address 12.1.255.255.255.0 exit interface loopback 1 IP address 1.1.1 255.255.255 exit, and I can also enable OSPF IP OSPF 1 area 0 and IP OSPF network 0.2 point. Copy it, paste it on R1. All the commands are not accepted. Where is the error? Check. Interface 0/1 network. Copy. Let me check now. Done. Now all the commands are accepted. On router number 2, interface G0/0, IP address is 12.2 and interface G0/1, IP address is 23.2. Copy, paste on R2, and finally R3. G0/0 IP address is 23.3 and loopback 1 IP address 3.3.3.3. Paste it over here. Now both the loopbacks are reachable or not. Test. Host name R1. Write the configuration. Host name R2. Write it. And host name R3. Write it. Just I have configured the IP. Addresses. From R1, check connectivity. Ping 3.3.3.3. Source 1.1. Why it's not reachable?
In R2, that G0/1 port is shut. Enter press.
R3.
R2, sir.
R2. So IP interface brief. 0/1 is not configured. Interface G0/1. No such. IP address 23.102.255.255.255.0. IP OSPF 1 area 0. IP OSPF network point to point. Ping, now ping is working. Now ping is working. Let me enable MPLS interface, or I can do one thing, router OSPF 1 and MPLS. MPLS LDP auto config. It will automatically enable MPLS on all OSPF enable interface. MPLS LDP auto config. Router OSPF 1 MPLS LDP auto config. Now here on router number 1 you can check so MPLS interfaces. You can see MPLS is enabled on 0/1. So MPLS LDP neighbor. LDP session is up. Here you can see 2 LDP session, right? And on R3 also LDP session. Now let me create one pseudo wire here on R1, between R1 and R3. Pseudo wire class. First of all, you will create a class. Define the name of your class, L2VPN, or I can say L2 link. I'm going to encapsulate it in MPLS. Encapsulate MPLS. Exit. Interface G 0/0 and X connect question mark IP address 3.3.3. Virtual circuit ID is 100. Pseudo wire class is L2.
L2 link.
L2 link. Line protocol is up. Okay. Now go to other side. Remote P router R3. Repeat the process. Configuration. Pseudo wire L2 link. Encapsulate it in MPLS. Exit. Interface G 0/1 and X connect 1.1.1. Virtual circuit ID 100. Yes, 100. And pseudo wire class L2 link. Wait for few seconds. R1. So MPLS L2 transport only. So MPLS uh, 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 so MPLS L2 virtual circuit 100. Virtual circuit 100 Ethernet destination address virtual circuit admin down config T interface 0/0 no set or interface G 0/1 no set. Okay, Ethernet is up. Good. Check it on R3 as well. Up. Let me access the customer router. There are some more troubleshooting commands. So MPLS forwarding table level 17 and no label for this L2 link. Great. So MPLS L2 virtual circuit 100 detail. Good. Now let me see here the L2 transport is working or not. I'm accessing customer edge router R4 C1 no and C2 interface D0/1 no set IP 10.1.1 255.255.255.0 and R5 interface G0/0 no set and IP address 10.192.255.255.255.0 ping 10.100. Here I have one LAN subnet interface G0/0 no set IP address 192.168.1.1 255.255.255.0 and interface G0/1 no set IP address 192.168.2.1 255.255.255.0. Now you can imagine here this topology like this, and my subnet is 10.1.1.0/24. Here IP address is 10.1, here IP address is 10.2. 10.1 and 10.2 are reachable, so your topology is now like this. Customer is router R1, another customer is router, one direct link, and here is your LAN. So you know how to configure routing protocol here, how to make reachability, right? Inside this link there is MPLS, right? So what I can do, I can simply enable OSPF routing protocol or any routing protocol, EIGRP, OSPF, whatever you want. Router OSPF 1 or router OSPF network 0.0.0 255.255.255.255 0 R4 router OSPF 10 network 0.0.0 255.255.255 and area 0. I'm expecting OSPF neighborship here now. This is point to point link. What happens? So IP OSPF neighborship is in two-way state. You can also change the OSPF network type. Interface 0/1 IP OSPF network point to point. Interface G 0/0 IP OSPF network point to point, and so IP OSPF neighbor is up, so IP route OSPF. You can see the remote site prefix is reachable from this next hop 10.1.1. Now test connectivity ping 192.168.1.1 and source 192.168.2.1. Ping is working. Similarly, you can configure BGP, EIGRP, any routing protocol. Now all the routing will be managed by you. So the backdoor link can be MPLS L2 link also, right? I told you earlier. What will happen if I build trace route, guys? If customer is going to trace route, will they discover MPLS router? Trace route 192.168.2.1 source 192.168.1.1 numeric. See, traffic is directly going to 10.2. Because these routers are forwarding traffic based on MPLS, right? These routers are forwarding labeled packet, not normal packet, labeled packet. So R1 is going to encapsulate your IP packet into MPLS. So either you can create, you can like purchase. These are payable service. You can purchase either L2 or L3 transport from the service provider, right? In the enterprises, commonly We are using MPLS L3 VPN. Between data center you can use L2 because only connectivity is not there. There are so many other things also like QS, quality of service, security, routing policies. Here we have only two sites, just we are enabling OSPF and communication is happening, right? But routing is not going to be so easy in production when you have thousands of prefixes, hundreds of sites. So let's handle routing service provider. There's one more way to create L2VPN. You guys can try by yourself. It will work. There is nothing tough or difficult. Now,
So as per you, which one will be better, L2 VPN or L3
no,
VPN?
it is not going to. I've told you many times, like we cannot say bike is better or car is better. All are better,
Okay.
right?
But if the requirement is same, okay. So in that scenario, which VPN will be better?
How requirement will be same.
Means let's say means let's take the example of bike and car. Okay. So my motto is only go from one destination to another destination.
Mm,
I don't need any luxury. So comparatively, bike will be cheaper, right?
mm.
So in that scenario, just I am going connecting this scenario. So if the requirement is same for from customer, so which one will be better, L2 or L3?
L3.
Okay, so reason for that?
Service provider is going to handle all the routing. They will configure all the routing policies. Even
Okay,
MPLS L3 VPN is cheaper than L2 VPN,
okay, that may be a reason.
right?
L2, L3 is cheaper. So any difference in convergence time or anything else?
No.
Okay, okay, thank you.
Welcome. Now, if we have again two sites and I have internet connection, both sides, like both sides are connected to internet service provider, like we have public IP address. Here my public is 1.1.1, here my public is 2.2.2. Now this is again responsibility of provider, how these two public IP addresses will be reachable. Question is here how I will connect to private sites. Let's say my private subnet over is 10.1.0/24 and 10.1.2.0/24. How will make communication between these two private sites over public network internet, right? Again you will create VPN. Which VPN? So we have now different VPN here for the internet transport. So before starting VPN over internet, we'll understand one other WAN technology, that is NAT. So NAT is the topic for tomorrow class. Tomorrow first we'll understand NAT. If time will permit, then I will also start VPN. Till then you guys can practice both types of connectivity over service provider network. You can also add more than two sites, like in my all lab I have only used two sites. You can also use three sites, right? Like I have one P router here, P1, P2 and P3. Side A, side B and side C, right? Service provider will have MPBGP session here, MPBGP, and here also MPBGP, right? So see how P1 is advertising, like P2 router, one provider router is learning some prefixes from one neighbor. Will it advertise to other neighbor? Yes or no? Whatever rule, basic rules we have understood in BGP, you can implement here also. You can also configure route reflector. in MP BGP, like route reflector for VRF. So whatever you have learned for IPv4 address family, you can implement for VPN-v4 also, for VRF also. Done.
Yes.
Right, but you have to practice those all scenario. Now my concern is to understand internet access and VPN over internet. That will be discussed tomorrow. That's all for today from my side, guys.
Okay, thank you.
You're welcome.
Sir, please share the recording.
Yeah, definitely I will share the recording. Give me some time.